Alright, in this video we're going to take a look at graphing some log equations and some transformations. So we'll start off with just some generic log. F of x equals log base b of x, and then we're going to note a couple of things. The domain is 0 to infinity. Remember, a logarithm is a happy creature. It only likes to be fed positive things. The range is going to be everything. And the range is the domain of the exponential, and the domain of an exponential was everything. Log and exponentials are inverses of each other. And we'll have a vertical asymptote of x equals 0. Then we're going to use this property, log base b of b to the r. Kind of like the bases cancel, exponential and logarithm of base b are inverses, so we're just going to be left with the exponent of r. So we're going to use that. And kind of the setup here is I'm going to use 3 points, and what is my asymptote? We can always graph more points if we need to. So we're going to do 1 over the base, which is base to the minus 1, and the logarithm is just going to give us the exponent here. Then 1 is b to the 0 power, and we're going to get the exponent when we plug it into log. And then finally, b to the first power is just b, and that's going to give us 1. So what we'll do is we'll do 1 over base, 1, and then base, and that's going to give us y coordinates of -1, 0, and 1. And we're going to do a couple examples of this here. We'll start out with graphing something pretty standard and then do some transformations with it. Okay. So we are going to graph log base 3 of x. Okay, we're going to go ahead and construct our table. So there's 1 over base, and remember 3 to the minus 1 is a third. Okay, and the logarithm will give us just the exponent, so we'll have 1 over base and -1. We'll have 1 comma 0 and the base comma 1. So 1 over base and -1, 1 comma 0, base comma 1. And we're going to go ahead and plot our points. We have a vertical asymptote at x equals 0, and we'll go ahead and connect our dots. So it looks a lot like the exponential. The exponential went this way, and they were reflections over the line y equals x. That's kind of how we developed the idea of a logarithm. Okay, so we connect our dots, got a nice curve, and then we're going to label what our graph is. And then we're going to do a transformation. So we're going to use the same base for convenience, log base 3 of x minus 1. Now if we're with the argument, it's going to do a shift to the right 1 unit. So all we're going to do is we're going to take our x coordinates here, we're going to move them to the right 1 unit. Everything else is going to stay the same. So what we get going here with our table is we're just going to, so the y coordinates aren't going to change. All we're doing is we're shifting the graph over to the right 1 unit. So 1/3 becomes 1 1/3. 1 becomes 2, and 3 becomes 1. 3 becomes 4. We're just adding 1 to each x coordinate. Alright, our vertical asymptote is also shifted to the right 1 unit. And we'll go ahead and draw that in. And then we will connect our dots. And you can see on the graph here that we've moved to the right one, moved to the right one, and moved to the right one. So that's consistent with what we just said. And now we're just connecting our dots and doing our graph. Okay. We're going to do one more on here. We're going to do this g of x is equal to log base 3 of -x. So if I got a negative with the x, that's going to cause a reflection over the y-axis. So we're going to reflect, like this person is going to get reflected over here. This person will get reflected somewhere around here. We're just reflected over the y-axis. So all that's going to happen is my x coordinates are going to change sign. Nothing's going to happen to the y coordinates here. Alright, so we'll have negative 1/3, negative 1, and negative 3. So all we're doing is we're changing the x coordinates. The y coordinates will stay the same. We didn't do any sort of shift left or right, so our vertical asymptote is still 0. And we can see we got a nice reflection with the original graph that we graphed, the one in black right here. Okay. We're going to do one more with this base, and we're going to kind of throw a bunch of stuff at you. And what we're going to look at is we're just going to handle each thing one step at a time, and then put it all together as we graph a more complicated transformation. So do 1/3, 1, and 3, and that's just our standard graph. So we'll just graph that very quickly, just to have it as something to look at as we go through the graphing process. Okay, and then we'll label our graph. And we're going to do this h of x function, which is negative log base 3 of 4 minus x plus 2. Okay. So what's going on here is a bunch of stuff. You see the negative in front of the logarithm? That's going to cause the log to reflect over the x-axis. So that would be a flip up and down. And then you got 4 minus x inside the logarithm. So the minus x is going to cause a flip over the y-axis, so that would be a left-right flip. Then you see you have the 4 in there, so we're plugging in with x first. So the reflection happens first, then we shift, and we're going to shift to the right 4 units. Then we're going to add 2 to the y coordinates. So the negative in front of the logarithm and the plus 2, that affects the y coordinates. What affects the x coordinates is the negative in front of the x. That's going to cause us to shift. That's going to reflect over the y-axis, and then the 4 is going to move us to the right. So we're going to take each x coordinate, and we're going to see what happens. Okay. So the 1/3 is going to be reflected around the y-axis. So the 1/3 becomes negative 1/3, and then we're just going to shift it to the right 4 units. Okay. So if we add 4 to that, so 4 minus 1/3 is 3 2/3. We take 1 and we reflect it, it becomes minus 1. And then we're going to shift it 4 units to make it become 3. Finally, 3 is going to be reflected to negative 3. And then we are going to shift it 4 units to the right, which will make it 1. So that's my x coordinates. And I'm going to go ahead and write down my x coordinates. So 3 2/3, 3 and 1. Now we're going to play kind of a similar game, but what happens to the y coordinates? So we're going to take each y coordinate. The first thing that's going to happen is it's going to be reflected over the x-axis by the negative in front of the logarithm. Then we're going to add 2 to it from the horizontal shift plus 2. Okay. All right. So negative 1 is going to be reflected to 1. And then we're going to put it up 2 units to make it 3. 0 is going to be reflected, but it's on the x-axis, so it just stays where it is. And then we add 2. And then 1 is going to be reflected to negative 1, and then we add 2 to that. And that's my y coordinates. So notice I just focused on what each x coordinate was doing, what each y coordinate was doing, to try to make it as simple as possible and using what I know about transformations. One other thing we need to note is the vertical asymptote got moved to the right 4 units. So it was originally at x equals 0, so if we reflect it as x equals 0, it doesn't move anywhere. And then we just slide it over 4 units. So we'll go ahead and put in our vertical asymptote, and then we already conveniently found all our points, so we just got to connect our, plot our points and then connect our dots. Okay, and that's probably about as yucky as they can get. Of course, we can do some sort of stretches and compressions, but this is plenty. Okay, but we're going to do one more, and that's one where we have a base that's a fraction less than 1, just to say that we've done one. So we're going to go and do one more, and this one will be a little quicker. So we're going to pick on 3 again. So we're going to use log base 1/3 of x. And remember, what we were using for our table is 1 over the base 1 and base, and that's going to give us outputs of -1, 0, and 1 respectively. Okay, so 1/3 to the -1, just take the reciprocal, so that is 3, and then the exponent there is -1. 1/3 of the 0 power is just 1, the exponent there being 0. 1/3 of the first power is just 1/3, and the exponent of 1. We didn't do any shifts left or right, so a vertical asymptote is going to be x equals 0. Looks like we'll go ahead and plot those points in. Put in our vertical asymptote, x is 0, connect your dots, and there you have it. So these will take a little bit of practice, so we just go off of this 1 over base, base to the 0 power, base to the first power, and that's going to give you their exponents, -1, 0, and 1, and you can do all kinds of shifts and transformations, and you just follow each coordinate, so you're not focusing on the whole thing at one time. It'll take a little bit of practice, but you've already done a lot of graphing, and you'll get the hang of this pretty quickly.